Okay, today's lesson is about parallelograms, our first in the quadrilaterals unit. The definition of a parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. There are four important properties to know about parallelograms. The first is that opposite sides are congruent. The second is that opposite angles are congruent. The third is that consecutive angles are supplementary. And the fourth is that diagonals bisect each other. So these first two problems, we're going to analyze the measures that were given to find the missing measures. So we know that those sides are congruent and these sides are congruent. Those angles are congruent. And then these angles are supplementary. So that would be 112 and 112. All right, so I'll just fill that in accordingly. So measure of segment AD is 8. Measure of segment DC is 15. Measure of angle A is 112 degrees. So is the measure of angle C. And the measure of angle B is 68 degrees. All right. Same idea with the number 2 here, since we're only looking at side lengths. So that's 27. This is 27. RU is 18, then SU measures 18. 7 for this part of the diagonal, so then that also has to be 7. And if the measure of RT, measure of segment RT is 30, then we have 15 and 15. Excuse me, so let's just fill it in. Measure of segment UT, 27. Measure of segment ST, 18. Measure of segment VS, 7. Measure of segment VT, 15. All right, let's keep it moving. We're given some measures of side lengths here. Let's fill those in. Do your side lengths in blue. 15. WX is 22. So we know that's 15 and that's 22. ZX is 32 here. So I can split that in half. 16 and 16. WT measures 10. So that's 10 and 10. So let's just do all of our side lengths first. So these four here. So the measure of ZW is 15. Measure of ZY, 22. The measure of segment TX here, 16. And the measure of segment WY, so add those two together, 20. Okay. I wanted to do all those side lengths first so I could erase, and then we can fill in the angles. So you don't have to erase, you can keep that there. It just got kind of messy when I tried to do it last time. So the measure of angle WZY, WZY. So that whole thing, 62 degrees. So we know that this is also 62 degrees. And then we do 180 minus 62, 118. So that's 118, and that's 118. Okay, and that all came from that first information there. The measure of angle WXT, WXT is 27. So that's this part. It's 27 degrees. And the measure of angle ZWT, this part right here, is 77 degrees. All right, so now we got to figure all this out. We got this. Measure of angle TZY. TZY, that's this angle right here in question. So that is an alternate interior angle. We're going to bring those back. Those are congruent, and we can use that because since it's a parallelogram, these sides are parallel, and then ZX would be your transversal. So then this is really also 27 degrees. And the next one, measure of angle XYZ. XYZ. We already found that. That's 118 degrees. Measure of angle XWT. XWT. All right, so this angle right here. So to do that, we just do 118 minus 77 and get 41. And then that last one, measure of angle XWT. XW. That's the wrong letter. XYT. XYT. And that is also an alternate interior angle with 77 here. So that's also going to be 77 degrees. 77 degrees. Beautiful. Yeah, let's try the next one. Excuse me. All right, we're just given angle measures here. So the measure of angle GHF is 34 degrees. So that's alternate interior here. Measure of angle HJF. HJF is 124 degrees. So then this angle is also 124 degrees. And the measure of angle FKJ, one of these now, is 79 degrees. All right, so it looks like we're going to have to kind of incorporate everything that we know already. So let's start here. Measure of angle GFJ. GFJ. So we need that whole part right there. So that's going to be supplementary with 124. So we just do 180 minus 124 to get 56 degrees. So that whole angle will be 56 degrees, excuse me. What's wrong with me? So measure angle GFJ, 56 degrees. Now I need the measure of angle FGH. FGH, oh, we already found that right here, 124 degrees. Measure of angle HFJ. HFJ, 34 degrees. Alternate interior. Measure of angle HKJ. HKJ. So that's this part right here. That's going to be supplementary because that makes a straight line with 79. That's 101. 101 degrees. Dalmatians. Just kidding. Measure of angle JGH. It's right here. All right, so let's get a little creative here. I know that this also has to measure 79 degrees because they're vertical angles. And now, looking here, I have a triangle. So I just do 180. No, I don't want that green. 180 minus the sum of 79 and 34. And that gives me 67 degrees. All right, a lot of prior knowledge that we're applying here. Measure of angle FGJ. FGJ. All right, that's the other part of this angle, so I just have to do 124 minus 67. And I get 57. So that's 57 degrees. Measure of angle FHJ. FHJ over here. That's just going to be this little part. So that's 56 minus 34, which is 22 degrees. And then finally with this problem, I know this feels like a lot, measure of angle GJF. GJF. That's going to be alternate interior with this angle we already found, which was 67 degrees. All right, so that was the first four, so that's just applying the properties, not really much problem solving there. So now let's apply some algebra with it. All right, we want to find the measure of segment YZ. So we already know that these are all parallelograms. Those two sides are congruent. So I just set up an equation and solve. So then that gives me 32 equals 8x. X equals 4. That's what the question's asking. I want to find the measure of excuse me, segment YZ. Boy. So that's 19 times 4 minus 31. Calculate that. Get 45. All right. NS and SQ are congruent, so that's 2x plus 7. This is 5x minus 23, and I want to find NQ, so that's a whole segment. So since diagonals bisect each other, I know that these are congruent. And to solve an equation, I just set them equal to each other. And to solve, so my value for x, then NQ is going to be 2 times 10 plus 7 plus 5 times 10 minus 23, which is 27 plus 27, gives us 54 units long. All right. Get into some angles. Angles are definitely the more tricky ones. Find the measure of angle R. So that's here. That's congruent to angle P. So I'm going to set up an equation to solve for x and then substitute that value in for the measure of angle P. So these are consecutive angles, therefore they're supplementary. So they sum to 180. So I combine like terms. And then I get 17 for x. And since I don't have an expression for r, I'm going to have to use the expression for angle P. So the measure of angle P is 3 times 17 plus 5. 51 plus 5, 56 degrees. Make sure you watch your units. All right, and then here, the measure of angle ABC is 115 degrees. Find the measure of angle ADB. So this is the angle we're looking for. So again, we have alternate interior angles used here. So I'm going to add those two angles together and set them equal to 115 degrees. Again, combine like terms. And I get x equals 12. And then I want to find the measure of angle ADB. So I'm just substituting that in for this expression. 72 minus 11 will give us 61 degrees. And then just some coordinate proofs, how we prove that parallelograms are parallelograms in the coordinate plane. So that's all properties that we use numerically and algebraically. Now this is when we're graphing. So there's three methods that we are going to work with. First method is proving both pairs of opposite sides are congruent. So these are opposite sides. So if side AB is congruent to side CD, and those two sides are congruent, so side DA is congruent to segment BC, then ABCD is a parallelogram. Since we're not actually measuring, like with a ruler or anything, we're going to use the distance formula for that. Another way that we can prove that a quadrilateral is a parallelogram is by proving that both pairs of opposite sides are parallel. So our little arrows, these two sides have to be parallel. So if that is true, and these two sides are parallel to each other, segment DA and segment BC are parallel, then we have a parallelogram. And that's our slope formula. Then the third way that we can do this is if we prove that only one pair of opposite sides are both congruent and parallel. So if segment AB is congruent to segment DC, AB is congruent to CD, and AB is parallel to CD, then we know that the figure is a parallelogram. And then in that case, we would have to use both the distance and slope formulas. All right, so we're going to do one of each here. We'll refresh you on those formulas. So the distance formula is the square root of the difference in the x's squared plus the difference of the y's squared. So looking at this, the quadrilateral is ABCD. Maybe we could just sketch that out and see what that looks like. Hypothetically, A, B, C, D. So we know we don't have to find segment AC, we don't have to find segment DB. So just went around in a counterclockwise motion. So the four segments measures I need to find are AB, BC, CD, and DA. All right, so I'll go a little slower with the first one. I'm going to do 1 minus negative 7 squared plus 2 minus 4 squared. And then when I look at those as separate terms, extra parentheses, 1 minus negative 7 is 8. 8 squared is 64. 2 minus 4 is negative 2. Square that, that's positive 4. So that's the square root of 68. I'll leave it there for now and see. Let's see what the measure of, we can even label it here, get that visual. See what the measure of segment BC is. BC, so 9 minus 1 squared plus negative 8 minus 2 squared. So we have 64, so that's 8 squared is 64, that's negative 10 squared is 100. So then we have 64. We're just looking to see if they're congruent. We could break it down more. You don't necessarily have to in this instance. All right, CD. In order for this to be a parallelogram, the measure of CD would have to be the square root of 68. So we have the square root of 9 minus 1 squared plus negative 8 minus negative 6. Doesn't matter the order that you go in. So then I have 64 plus negative 2 squared is 4. Square root of 68. What do you know? So far, so good. We just need to find dA. dA, got that. Anyway. So I'm subtracting the first and last. So 1 minus negative 7 squared plus negative 6 minus 4 squared. So that's 8 squared, 64, plus negative 10 squared, 100. Square root of 164. Yes, sir. All right, so we have two pairs of congruent sides. So I know that AB is congruent to CD, and BC is congruent to DA, segment DA. Therefore, yes, ABCD is a parallelogram. I know you were worried. You were like, "Oh, I hope it's a parallelogram. That sounds fun." All right, let's use our slope formula for number 10. Reminder on that slope formula, m equals difference in your y's divided by a difference in your x's. So we have quadrilateral EFGH here. So just to get a visual for that, maybe this one goes this way. EFGH. So the sides I want to find the slopes of EF. I want to find the slope of FG. I want to find the slope of GH. And I want to find the slope of HE. So I'm using those subscripts there to signify which segment I'm using. So for EF, subtract my y's over subtract my x's. So that's 2/6, which is 1/3. Cool. FG, same idea. Subtract my y's, negative 10. I'll do the work, sorry. 0 minus 10 over 2 minus 6. Negative 10 over negative 4. which reduces to positive 5/2. And let's see if GH is parallel. GH, so that's -2 minus 0 over -4 minus 2. So it's -2 over -6, which is 1/3. So far, so good. Let's see what the slope of segment HE is. So -2 minus 8. Sorry, my handwriting is really decreasing. Over -4 minus 0. -10 over -4. We've seen that before. Haha. That's my second pair of parallel lines. So, hooray! Segment EF is parallel to segment GH, and segment FG, that's a G, is parallel to segment HE. So, yes. Guys, what's up with this handwriting? Many apologies. It has to be the pen, not me. EFGH is okay, seriously, that isn't me. I think we have a lag situation going on. Maybe I didn't close out my COD game. Alright, last one. Using the distance and slope formula to determine if the figure is a parallelogram. So, here's, we're going to use both formulas. We already have them, so I won't rewrite them. STUV, never mind. So it looks something like this. STUV. We would just need to know that, for example, these two sides were both congruent and parallel. So I can find the measure of ST. Keep this in black, just like all the other ones, right? Probably. So the measure of ST, that's a 2. It's a 1. Okay. So difference in my x's, so that's 9 squared. Difference in my y's, 5 and 7, are 2 apart. I promise I'm not trying to make my handwriting worse. I really think it's the computer. So that's the square root of 81 plus 4, square root of 85. All right, so let's find UV. So that's the difference in your x's is 17 squared plus 1 and -1 are 2 apart. All right, these already I can tell are not going to be congruent. So that's 289 plus 4, which is 293. Square root of 293. So already we can tell here that those sides are not congruent. Therefore, we don't have a parallelogram. But we're still gonna we're gonna do it anyway. Finding the slope. So the slope of segment ST and the slope of segment UV. Seven minus 5 over 10 minus 1, 2/9. And then for UV, 1 minus -1 over 14 minus -3. 14 minus -3. 2/17. Not parallel. All right, so therefore, no. STUV is not A parallelogram. All right, I know this is kind of a long one. There's a lot of work here, but we believe in you. We know you can do it. And if you need any help, please reach out. See you in class Monday or Tuesday, and again for office hours on Wednesday. Reach out, take care, stay safe, enjoy the sunshine. Bye.